Okay, for 4E we're talking about power functions, and there are three different types of functions you need to know about. There's this guy here, okay, which is called the hyperbola, or hyperbola, or however you want to say it, but it's called the hyperbola. Alright, now one thing I want to mention, guys, is in one of the previous videos we talked about horizontal translations and vertical translations and stuff like that. This is where it all comes into play again. This one is centered around, remember we were talking about where it was centered around? Okay, this one is centered around the origin as well. So this one is centered around 0, 0. Okay, so I'm just going to write that down. Centered, I don't know if that's spelt right, but who cares, around 0, 0. Okay, I really don't, it doesn't look right. Yeah, I don't know. So where does it go, in there? There you go. Alright, centered, is that better? Alright, so centered around 0, 0. So if you are translating that, so the standard form of that is 1 on x. Okay, so if you're translating that, remember the translation we had A's, B's, C's, D's? No, we didn't use D. What did we use? We had A, B and C only, wasn't it? Yep. So if we're going to apply that same principle, it's A over x minus B plus C. Okay, and they all do the same thing. So A is still your dilation factor, B is still your horizontal translation, and C is still your vertical translation. And you still have to reverse the sign of B when you bring it out. So if it's minus B, you're moving it this way, you're moving it to plus B. Okay, if it's plus B, you're moving it that way to minus B. And remember that you are centered around 0, 0. Okay, so the same things apply as what we talked about last time we talked about translations and everything. You're centered around 0, 0, move it first, and then go from there. Alright, so that's hyperbolas. The next one is the truncus. Alright, which looks like this. Okay, and again you can center that around 0, 0. Okay, so use that centered around 0, 0 again. I should write down the name of it. Truncus, centered around 0, 0. Alright, so it's centered around 0. Look, that looks like centeed, but anyway. Centered around 0, 0 again. Okay, so all your translations and stuff go from there. Okay, so the formula for this one is y on x squared. Y equals 1 on x squared, sorry. And your translation in type 1 is the same thing. Y equals A on 1. No, what is it? X minus B squared plus C. Okay, so same thing. All the same translation factors as in that last one. Alright. And then there's one more you need to worry about, and that is the square root function. Okay. Which starts at 0 and goes up like that. Oh, I didn't draw it in red. Oh, I've ruined it. Ruined everything. Alright. And again, I would center that one around 0, 0. Okay. So this is the root function. Okay. Square root x. And then the translation form is y equals a square root x minus b plus c. Okay, that a is not here. Okay, it's not there. It's not like the a root of x minus b. It's not there. Okay, it's out the front. It's multiplied. Okay, and again, that one I would center it around 0, 0 and move it from there. Okay. Alright, so we're going to translate these guys around using these formulas, alright? So we're just going to concentrate on this one first. So I'm going to do the same thing I did last time, okay? My standard 1 on x graph looks like what? A truncus. No, idiot. A hyperbola. Okay, so it looks like that. Centered around 0, 0. Okay, so now we're going to move it and see what happens. So we're going to move it up 5. Okay, so the whole thing is going to move up 5. Okay, and we get this. Called a asymptote. Okay, a line that it approaches but never touches at 5. I'm then going to shift it plus 1, so I'm going to shift it this way. Okay, and we get an asymptote here at x equals 1, and I should say that asymptote is at y equals 5. Okay, and now all I've got to do is take into account, so we're working with the orange graph, the dilation factor. Okay, so let's think about what that does. So let's say x is 1. 2 divided by 1 is? 1 divided by 1 is?
1.
So is it going up quicker?
Yeah.
Yes. So if my final graph is centered around this point here, okay, it's centered around 1, 5, okay, it's actually going to be a steeper graph because it's going up quicker. So the green one is my final graph. Okay, make sense? Same thing applies to all the others. So if we have a look at this one here, my standard x squared graph, okay, looks like this. Okay, this says I'm going to shift it up 1, so I'm going to shift the whole thing up 1, and I have an asymptote at y equals 1. Okay, my dilation factor of 3 divided by 1 squared is 1, 1 divided by 1 squared is 1, 3 divided by 1 squared is 3, so it's again going up quicker, so it's going to look like that, okay, with the orange being my final graph. Okay, and then this one here, my standard square root graph, looks like this. Okay, however, it's a negative one, so it actually should look like this. Okay.
Could you cover the negative x and then the whole thing negative?
So yeah, so negative x flips it this way. The whole thing negative flips it this way. We talked about that in the last one. Alright, we talked about that in the last video. Alright, so negative x within the thing flips it this way. Okay, so we're coming out here. We're actually moving it negative 3 as well. So if I do that translation, we're going to move it negative 3. Here's negative 3. And we're going to move it down 1 as well. So I need, what? Green for that, isn't it? Yeah, down 1. No, I don't know, I've messed up all my colours. So we're moving it down 1, so we're going to start here and do that. Okay, and there's no dilation factor here. So that graph there is my final graph, the green one. Alright, as dodgy as it may seem.